Hey guys, welcome back. I wanted to have a little review before your exam on Friday, but we can't do that if we don't have if we don't need it, right? So if you guys need some practice problems, or if you need some further clarification on some of the topics from Chapter 9, go ahead and reach out to me. I can set up a Zoom session tomorrow or Thursday, or even Friday morning. Just let me know, So I'll be waiting on your feedback. But I did want to review how to complete the square before we begin chapter 10. So some of the things that we've already done in chapter 2 is how to take a quadratic function that looks like this and convert it to a quadratic function that is in vertex form, right? It was in vertex form. If you remember, the vertex with the original function was negative b over 2a, and then you had to evaluate the function at that value, and then the axis of symmetry was negative b over 2a, right? Well, when we converted it to vertex form, the axis of symmetry was h, and the vertex was h comma k. So it was a little bit easier for us to graph, but the whole point was to take it from here and make it look like this, right? And that process was completed by completing the square. So let me just review that real quick on how to complete the square. So when we're switching from the general form to the vertex form in a quadratic function, our goal is to find the factored form of f of x. That looks like this, or like this, right? So our job is to factor it in a way that we have this, right? You can definitely have a constant in the outside, which is totally fine. That just means it's a vertical translation. But our job is to make it look like this, all right? So one thing I wanted to just show you real quick is if we were to expand these two, right? In order for it to factor nicely like this, then it must look like the expanded form. So the first one, if you were to expand it, it's going to be x minus c times x minus c, and you perform the distribution, you're going to get x squared plus 2cx plus c squared. And then if you expand the other one, where it's x plus c, and again you go ahead and you take care of the distribution here like that, you're going to get x squared plus 2cx plus c squared. Oh, and you know what, I just realized I put a plus there where it should have been a minus 2c. Alright, so if it's going to factor nicely into one of these two, right, then it's got to look like these guys right here, right? Notice how this c and this c are the same. So you have 2 times c, and the other one is c squared. So our job pretty much is to find that c value so that we can factor it into an x minus c squared or x plus c squared. So if we have a function like this, right, then what do we need to add to this function so that when we factor it, we get something like this? I'm going to use the plus because it's got a plus right there, right? So what value do we need to add here so that this f of x function factors nicely into that g of x function, right? So what's c value? Well, if we go back and expand this, remember, we get this. Well, it turns out that this c value that we're looking for is the coefficient of the x, right? Which in this case is 8. So remember, if it's going to factor into this guy, then it's going to look like this, which we partially have up here. We kind of have that already up there. All we got to do is set up the equations. What equations? The coefficients. So notice, if it's going to look like this, then it must look like this. It's expanded. So now we compare these two, f and g. We compare them in a way that we notice that x squared is the same. We know that this mystery number is c squared. And we also notice that the coefficient of x in this case is 8. And on the perfect square, right, the one that we're trying to factor, is 2c. Well, we can solve for c by solving that simple one-step linear equation. So then we get c equals 4. So now what number do we need to add in order for f to factor nicely? Well, it's saying you need to add c squared, right? Which we have 4. So this guy's going to be 16. So x squared plus 8x plus 16, it's going to give us a factor of x plus 4 times x plus 4, which is x plus 4 squared. Alright? So this is just to show you what it means to complete the square, right? We ultimately have a function that's squared, it's a perfect square, and we need to find that value that gives us that factor. Alright? So that's just a way of explaining finding the value, right? So how is it going to look like in this chapter? Well, we're going to begin with section 10.2, which is parabolas. And then we're going to move on to ellipses and hyperbolas, where you're really going to have to know how to complete the square. Alright? So let me just do 2 more examples on completing the square. The first one is x squared plus 6x plus 11, right? This doesn't factor nicely. It's not a perfect square, but we can find the value that we need to add, right? Like in other words, it's x squared plus 6x plus that mystery value for it to factor nicely plus 11. So what value do we need to have there? Well, we do the exact same thing we did earlier. We know for a fact that this is going to have to be 2c. So we take 6, we divide it by 2, we get 3. And we know we need to add c squared, which in this case is 9. Now, because before we were actually just trying to find the value to give a perfect square, now we have a function, so we just can't add 9. This is where we do the whole adding and subtracting, so that we don't change the value of, we don't change the function to something else. So it's going to be x squared plus 6x, and then we add that value we need to make it a perfect square, and then we subtract that value because 9 minus 9 equals 0, and then we add the value that we had to begin with. So now we did that whole thing because now we know for a fact that this guy right here factors nicely. Well, what does it factor into? It's going to factor in to x plus 3 squared. And now on the outside you have minus 9 plus 11, which is plus 2. Alright, so we took the function, we took this function, we completed the square, which is this process right here. And then we have a perfect square here. Even though we're adding the 2, it doesn't change the fact that this is a perfect square. All right. So then this is our end result, which we're going to need when we're doing parabolas, ellipses, and hyperbolas. So now I want to show you just one more example when you don't have a 1 as a leading coefficient. So when you don't have a 1, right, then you have a function, I'll try to make a simple one, x squared plus 12x plus 7, all right? So this one doesn't factor nicely. So then how do you handle this? Well, if you jump into finding c here, then it's going to be wrong, okay? And one way to indicate, one way for you to check to see if it's wrong or not is by taking your factored form, expanding it, then you should get back the g of x function we started with, all right? So what you got to do is you got to be able to handle this 2 right here. So what I'm going to do is I'm just going to factor it out, 2, from the first 2 terms, from there. So now if we look at this guy right here, now this one has a coefficient of 1, which we can begin to complete the square. So g of x equals, we have a 2 in the outside. We have x squared plus 6x, right? So this is where we take the 6, we divide it by 2, we get 3, 3 squared, we get 9. So 9 is the c squared. That's the one that we need to add and subtract to the original equation. And now it's just a matter of simplifying. This right here is the perfect square that we're looking for. So then we get 2 parenthesis for the factor, x plus 3 squared. We still have a minus, this factor nicely, we still have a minus 9, so minus 9 plus 7. So now all we have to do is distribute the 2 times that, that's x plus 3 squared. And then 2 times negative 9 is negative 18. And in the outside we have a plus 7. So now we go ahead and we handle the negative 18 plus 7 and we get negative 9. So this answer right here is the standard form for g of x by completing the square. Alright, so when we move on to ellipses and hyperbolas and you're having to complete the square again, come back to this video. If it's not enough, reach out to me. Alright, don't hesitate to reach out to me. Remind Google Classroom, email. I'm here to help you guys out. I hope this little mini review helped. And check back so we can do parabolas, ellipses, and hyperbolas, and all the other good stuff. You guys stay safe. Have a good one.